Welcome to the webinar on how to use air conditioners in COVID-19 times. This webinar is being presented by IBC in association with ISHRAE, that is Indian Society for Heating, Refrigerating and Air Conditioning Engineers. Friends, my name is MP Agrawal. I am associated with ISHRAE for over 20 years. I am the presidential member of ISHRAE and also the national chair for Apex Advocacy. The COVID-19 pandemic has adversely impacted virtually every nation on the earth. It has created tremendous suffering and anxieties amongst all. However, at the same time, this pandemic highlights the great importance of HVAC and our industry, along with the very need to work together to overcome this menace. During these times, the webinar will be very informative, contemporary, and useful to all of us. To begin with, I would like to invite Mr. Pradeep Mittal for his welcome note. First, I will talk briefly about him. Mr. Pradeep Mittal is an MBA and a by profession. He has attended Technology Exchange Program on Energy Efficient Buildings Material held in Germany. Apart from his involvement in built environment, he is an active member of many social and philanthropic societies. He is holding the prestigious post of National Chairman of Akhil Bharatiya Agrawal Sangathan. He is the president of Snehipat, an organization working for handicapped and the old age people. He is the vice president of GIEO Gita, that is the Global Inspirational and Enlightenment Organization of Srimad Bhagavad Gita. This organization is the message of Bhagavad Gita to around the world. He is the General Secretary of Shri Ashram Trust, which is constructing Gyan Mandir and of rupees 100 crore project at Kurukshetra, which would be the highest in the world. He is also the chairman of Shri Ram Technical Educational Society, association with the Indian Building Congress from the very inception of IBC. He actively contributes technical and other activities of the IBC. He has served as vice president for 3 years and is honorary secretary for 8 years. Presently, he is holding the position of the president of IBC. I would now request Mr. Pradeep Mittal to give a welcome note. Mr. Mittal, please.
Namaskar.
Namaskar, sir.
Shri Anand Kumar ji, ADG CPWD, Shri Richi Mittal ji, the president of the ASHRAE, Shri Vishal Kapoor ji, the chief of technical committee, Shri Gautam ji, also the head of the technical committee, Shri MP Agrawal ji, Shri CL Verma ji, and I also want to name our Shri OP Goel, the founder president of IBC and former DG CPWD. Only on his advice, IBC is working since last 27-28 years. आज मैं इस वेबिनार में उपस्थित सभी मित्रों का और जो भी डेलीगेट्स या जो इसको सुनने के लिए हमारे मित्र जुड़े हैं उन सभी का हार्दिक अभिनंदन करता हूं। IBC के विषय में मैं संक्षिप्त में बताना चाहूंगा कि IBC इंडियन बिल्डिंग कांग्रेस का गठन 1992 में हुआ। इसका उद्देश्य बिल्ट एनवायरनमेंट क्षेत्र में जुड़े हुए सभी इंजीनियर्स, आर्किटेक्ट्स, टाउन प्लानर्स, बिल्डर्स, बिल्डिंग मटेरियल्स के मैन्युफैक्चरर्स इत्यादि को एक मंच पर लाकर टेक्निकल नो हाउ को शेयर करने के लिए इंडियन बिल्डिंग कांग्रेस की स्थापना की गई। CPWD, रेलवे, DDA, MES, HUDCO, CBRI are its founder members, and afterwards, few years back, we also added NBCC as its pillar member. IBC is publishing books, arranging technical seminars from time to time on different fields all over the India. Now, आज जो ये वेबिनार का आयोजन इंडियन बिल्डिंग कांग्रेस ने ISHRAE के साथ मिलकर किया है, एक ऐसा टॉपिक हाउ टू यूज एयर कंडीशंस इन कोविड-19 एक बड़ा महत्वपूर्ण विषय है। मैं समझता हूं इस वेबिनार से न केवल टेक्नोक्रेट्स और टेक्निकल लोगों को बल्कि हिंदुस्तान के आम नागरिकों को और आम जनता को भी बहुत लाभ होने वाला है। आज जो एक भयंकर महामारी पूरे विश्व में फैल गई है, जिसने एक ऐसा रूप ले लिया है कोरोना के रूप में कि आज पूरा विश्व परेशान है। हम हिंदुस्तान में तो आज फिर भी अभी बहुत दूर हैं, लेकिन आज यूएस और ऐसी ऐसी बड़ी महान शक्तियां भी इसको बहुत परेशानी के साथ जूझ रही हैं। और जैसा सुनने में आता है कि आज एक इंसान के छींकने से, खांसने से जो भी ड्रॉपलेट्स गिरते हैं वो हवा के जरिए दूसरों तक पहुंचते हैं, और एयर कंडीशन या वेंटिलेशन एक बहुत बड़ा ऐसा माध्यम है, उसके जरिए ये दूसरे तक पहुंच सकते हैं। तो आज हमारे बीच में रिची मित्तल जी, विशाल कपूर जी, गौतम जी, अन्य हमारे ऐसे विशेषज्ञ आए हैं जो हमें अपना मार्गदर्शन देंगे, सभी को ज्ञान देंगे कि किस प्रकार से हम इस कोविड के टाइम में एयर कंडीशनर को इस्तेमाल करें, जिससे कि इसका लाभ पूरे सबको मिल सके और ये बीमारी आगे फैले नहीं, इसको रोका जा सके। मैं पुनः इंडियन बिल्डिंग कांग्रेस की ओर से, ISHRAE की ओर से आप सभी का हृदय से स्वागत करता हूं, धन्यवाद करता हूं, अभिवादन करता हूं, और पुनः मैं विनती करता हूं हमारे इंडियन बिल्डिंग कांग्रेस के वाइस प्रेसिडेंट श्री अनंत कुमार जी, जो ADG CPWD हैं, कि वो आए और अब आज के हमारे विशेषज्ञों का परिचय कराएं। बहुत धन्यवाद। पुनः सबको नमस्कार।
हेलो, आवाज आ रही है?
Yes, sir, we can hear. Yes, sir, आ रही है sir.
Welcome all the panelists, distinguished guests, and all the persons who have joined this webinar on today's topic. As our president has told you that IBC was planning to have some seminar on the relevant topic, and it just came to our mind that we can organize this seminar on this air conditioner topic, as it is in news, I would say, in national news, through print media or through television, and rather somebody has filed a PIL in the High Court that air conditioner in the High Court building should not be used. And it came handy that by that time we have issued the circular regarding the how to use air conditioner by this, the guidelines provided by ISHRAE to us. And the High Court has asked us now to form a committee, expert committee, to suggest the means and ways how to use air conditioner and whether this ultraviolet system can be installed or not. So the today's topic will be, I hope, will be very relevant and give the insight to the persons. In fact, 2-3 days back, I read in the newspaper also, in the Hindustan Times, that AC airflow spread disease in China restaurant. It was in Hindustan Times on the 21st April. And on the second, third page, they have given the complete diagram where the airflow from suction to discharge was shown, and that they have identified which table got affected and due to what it has been got affected. Table 1, 2, 3, see, they have given complete diagram. So on this topic, we are organizing this seminar. The topic was accepted by our executive committee, and we will deliberate for 1 hour. And before not going much into the detail, as the expert will throw the lights on this subject, I just want to give brief introduction of our experts panelists. To start with Sri Richi Mittal. He is a director of Overdrive Engineering Private Limited, a company specializing in energy efficient design, passive and engineering in air conditioning and cooling system, indoor air quality and geothermal for enclosed facilities, energy audit, green building, third party commissioning and testing, adjusting and balancing. He is a graduate engineer from BIT Meshra and postgraduate from Delhi College of Engineering, graduated in 1984. Postgraduated. He has more than 36 years of experience in this industry and is a guest lecturer in many engineering colleges, including IITs. I have a very long list for which he is representing, and probably it will be difficult for me to read because the list is very long. So it gives his expertise in many fields. But right now, you can consider him as an expert on the air conditioning, HVAC, heat pumps, and many more. So now our second panelist is Mr. Vishal Kapoor. He is the IIT Roorkee alumni, I also graduated from IIT Roorkee in '84. He is graduating in 1993. And he is 50 years of age and engaged with HVAC industry for the last 24 years. Managing Director of Meho SCP Air Conditioner System. He is a large HVAC contracting and services company based out of Kolkata and Delhi and doing projects all over East and North India. The group employs approximately 450 persons and is also one of the country's largest exclusive channel partner of Carrier Air Conditioning and Refrigeration Limited, handling the whole spectrum from splits to package to VRF to chillers. He is a partner in Environmental Protection Services Company, which offers HVAC remediation and IEQ services. He has served ASHRAE in the capacity of National President during 2017-18, National Treasurer during 15-16, and many other committee level positions. Currently, he is National Chair ISHRAE Technical Committee and also takes care of the international relationship of the society. Also chairs the COVID task force of ISHRAE responsible for bringing out the guidance document for air conditioning and ventilation. And Mr. Gautam Baliga is a director of Opal HVAC Engineering Limited, a company which specializes in design and build of pharmaceuticals, healthcare and industrial HVAC system. He is a graduate mechanical engineer from IIT Roorkee, IIT Kharagpur, 1979 batch, and has worked with Voltage Limited for 8 years. He is an active member of ISHRAE, in which he is one of the editorial board of ISHRAE Air Conditioning and Refrigeration Journal, member of the ISHRAE Technical Committee, member of IEQ Standard, and has chaired ICP, that is ISHRAE Certified Professional, and IIE. He is currently chair of the Healthcare Technical Group, which has been tasked with coming out with guidelines for HVAC and healthcare facilities this year. Apart from this, I would just share with you, after issuing these guidelines through CPW website, we have received some comments and some requests. Somebody from this dental hospital, he has also said that our concerns in your guidelines are also to be addressed, as the dentist, they say, when the person is treated, he spits more and more, and the danger of spreading COVID through that patient is also to be taken care of. So I hope Mr. Agarwal, Mittal Saab and Mr. Kapoor, Mr. Baliga, all these eminent speakers will also consider this point while deliberating. Thank you very much. I welcome all again. Thank you. Let us start, please.
Yes, sir. Thank you, Mr. Anand. Thank you, Pradeep, sir, and thank you, MP, for having this. Good afternoon, friends. It is my pleasure to have a joint webinar with Indian Building Congress related to air conditioning ventilation through webinar. Anand, sir, just to share a point that we are already talking to Indian Dental Association, and very soon you will see us on the same platform, and we will definitely send you a link on that. I would like to thank the ISHRAE COVID Task Force set by ISHRAE Technical Committee with ISHRAE chairs of technical groups for preparing this document, along with ISHRAE HQ and IT committee, which has worked more than 5 to 6 hours every day since the launch of this document, which was done on 13th of April. A brief about ISHRAE. ISHRAE, the Indian Society of Heating, Refrigerating and Air Conditioning Engineers, was founded in 1981 at New Delhi by a group of eminent HVACR professionals. ISHRAE today has over 30,000 HVACR professionals and student members. ISHRAE presently operates from 43 chapters and sub-chapters spread all over India with HQ in Delhi. So our reach is all over India. In our endeavor to disseminate knowledge, ISHRAE is not stopping while fighting with COVID, and have already started using digital platform to reach and connect with webinars, as the one we are doing it right now. Since beginning of lockdown, ISHRAE is conducting around 8 to 10 webinars for our members to freshen up the knowledge at the comfort of their home. It is led by the team of elected officers who are members of society working on a voluntary basis. All of us are volunteers here, sir, and collectively called the Board of Governors. I'll just run through the ISHRAE's objectives, which are advancement of art and sciences of heating, ventilating, air conditioning, refrigeration, engineering, and related services. Continuing education of members and in other interested persons, the said sciences through lectures, workshops, product consultation, publication, exposition, and webinars. Career guidance and financial assistance to the students of said sciences. Encouragement of scientific research. I would like to thank each one of you to participate in this digital panel discussion. This document is available for free download on our ISHRAE website, and would request all those who are not yet a member of ISHRAE to please join and participate in this journey of ISHRAE to disseminate knowledge to all. Just to share that Mr. Anand has already said that CPWD has already adopted the document. I'd rather share that Sir MES has also very recently adopted this document, and this is all. Thank you to all. With this, please stay safe and home as per government directives. Take care. Thank you. And over to you, Vishal, to take over on the technical presentation. Thank you.
Thank you very much, everyone. Mr. Anand Kumar, it's always an honor to be introduced by your senior alumni, because it's actually from all of us, whichever institute we might be coming from, connecting to your college alumni is a very, very important thing. Is my screen visible to everyone?
Yeah.
So can I request?
Just to share that our attendance shows 501. Probably that is the maximum limit we can accommodate.
That's right, sir. We are getting requests coming in for more people, but we can't have more than 500 joining. So it's a wonderful, wonderful event, and really nice to have everyone.
Even in the, I would say in the hall also, we could not get 500% at a time, but now this 500.
So I think Vishal, if you can start. Thank you, sir.
Yeah, I can start. Thank you, everyone. I think if the panelists can switch off the videos, then for every delegate, they can view the whole screen. So it'll be nice. I'll also be turning off my video now. Okay. So Namaskar, good afternoon, and welcome to this very important session. And I was going through the website of IBC, and everywhere it talked about built environment as the main subject of everything that IBC does. And fortunately, the discussion that we're having today is all about the built environment. It's all about indoor spaces and the effect of COVID on indoor spaces and the effect of indoor environment on COVID-19. So as Richie has already told you, that we wrote this document, developed this document because there has been a lot of coverage in the media at different circles, people talking about air conditioning and ventilation, whether it's good, whether it spreads the virus, whether it prevents the spread, should we put it on, should we not put it on, etc. So we thought, as being the representative body of the air conditioning industry, and as a body comprising of engineers, as a body comprising of individual engineers, just for clarification, there are no companies who can be members of ISHRAE. These are all individual engineers. So combining the entire technical strength, we should be the right ones to tell everyone that what is the true fact and how do we go about it. And while developing this document, please note this document is not based on a research paper, because there's no time to do research at this point. It's too short a time. Research takes a couple of years, if anything more. We have sourced documents and studies from across the world. We have very good relationships with all parts of the world, a lot of associations, whether it's in USA or Canada, all over Europe, Australia, China, Japan, Korea. We spoke to all our colleagues over there in the same industry. We sourced their studies. We sourced studies done in India. We sourced studies done on the previous viruses, whether it was SARS or MERS, etc., or the influenza flu, etc., to get to a point and put everything in this document combined under various applications. Broadly, this document is in three parts. One is the conditions, the indoor conditions that should be there in applications, residential, commercial, and healthcare, and how to operate and maintain. So this is the document that we talked about. It's available for free download from ishrae.in. You can all visit this website after this webinar and download this document freely at your time. Let me start with the indoor environment. As was rightly talked about, sir, that there is a lot of talk going on as to how this virus spreads in the air, etc. Now, please note that any individual when it talks or breathes or sneezes or coughs, we are all generating huge number of particles of varying sizes from 1 micron to large particles into this air. And these are all traveling long distances. Specifically to do with this virus or any other flu kind of a virus, The virus itself is very, very, very tiny. It is just 0.1 microns. You can't even imagine what 0.1 microns mean. But when it comes out of someone's mouth or nose, it comes out encapsulated in droplets, like typical mucus droplets that come out of everyone's mouth. Now, when these droplets are larger droplets, then they will drop down within 4 to 6 feet of the person who's infected, and they will come on the surface. And that is why we always say, clean the surface, wash your hands, because if you touch such a surface and then touch your mouth or nose, there are chances of the other person getting infected. So these droplets come and fall within 4 to 6 feet. Some might drop up to 6 to 8 feet. Then there are the droplets which are smaller in size and which can travel longer distance. They can travel up to 6 meters. There have been some reports we talked about that a droplet, when somebody sneezes aggressively, very aggressive sneeze, can travel even up to 30 odd feet as the distance of traveling. Nothing been proved properly, but there are talks of it traveling those long distances. If somebody is standing near a person, when the person coughs, the droplet can come and fall directly on the other person's face. That is why we're saying both people to wear a mask. Remember, these droplets that we're talking about, whether they are those large droplets which are say 100 microns which come out, have a float time of just around 6 seconds. So within a few seconds, they will actually just settle down on the surface or on a table near you. The smaller the particle, the longer it will remain in the air. And the very, very small particles have been talked of remaining a few days in the air also and floating around. Also, these droplets will shrink. So when mucus falls out from a mouth onto a table, that mucus basically is all liquid and water. In dry conditions, that water will evaporate, and what is remained behind will be this small virus particle. So this summarizes all the possible ways that this virus can travel. So you look at a person coughing, some droplets are falling immediately on the floor, and those are called indirect contact. Means the person sneezes, larger droplets, they fall on a table or on a wall or on a door somewhere. Somebody else touches those things and gets infected. That's why it's called indirect contact. So wash your hand, keep your distance. Then there are droplets which are called as direct contact. Means the medium-sized particles which could fall directly on a person. So you're standing 6 to 8 feet, 5 feet from a possible infected person, and with him talking or sneezing or coughing, etc., or even normal breathing, the particles can fall on you and you get infected. So that is basically talked of direct contact, and that's why we say social distancing and mask. Then we have the lighter, smaller droplets which remain in the air for a longer time. Now these are what we are going to be talking a little bit more, because those are really what we are concerned with. The other kind of droplets can be controlled by social distancing, hygiene, personal protection like masks and gloves, etc. The ones that are in the air, we need to understand how they behave. There are some other transmission routes. WHO has also confirmed this is the fecal route of transmission through toilets. Whenever, especially when it is being flushed after usage, the plumes, the gas will rise out, and those could be also infected. So it has been advised to shut the lid, run the toilet exhaust, immediately keep the toilet exhaust on with all, and before flushing, shut the lid. Also, this virus can travel with dust particles, PM, different sizes of particles, the particulate matter. And also, this virus, especially in healthcare and hospitals, you must have read about this, is getting deposited on people's clothes, on shoes. And when you walk, and even if you take off the clothes, when you're walking, somebody else will, because of that walking and the movement on the floor, these particles can get resuspended into the air also. So all this are various ways that this virus is basically getting transmitted, because it is very important to understand. As of now, there are no percentages made in the world as to which one is causing more transmission and more infection, etc. But obviously, the larger ones have been found out to be indirect, that means through surfaces, or direct transmission are the ones that are causing the maximum problem. Also, because we are under lockdown in most countries, so people are not moving in public spaces. So everything is down to these two as the main criteria. Now, a very important question, which I'm sure all of you are being asked, wanting to ask, wanting to answer: is the virus airborne? Can the virus spread through air conditioning? So, the virus being airborne or not airborne, there are no 100% confirmed studies of that, but there have been studies made by both WHO, ICMR, etc., that this small nuclei of the virus, when it remains in the air, the infectivity level of this, that means how much infection can this virus cause, the infectivity level of this virus drops down drastically. That's why we said that air conditioning can be used, Obviously, one has to use it with some precautions, which we'll talk about. In an enclosed room, where there is no ventilation and the room air is totally stagnant, the room air is fixed out there, yes, the virus can travel from person to person through the air. Hence, we talked about social distancing, and we will now talk about ventilation. Broadly, please understand, there's nothing better than a mechanical system to control ventilation and filtration. There's nothing better. You cannot ventilate a space by natural ways. Even if you can, there is no way that you can control. You can keep windows open. You can assume that air is coming in and air is going out through cross ventilation, but you cannot control it. You cannot guarantee that air is moving in that direction with the right velocity to actually ventilate my room. A mechanical system is controlled. It is controlled by fans and motors and ducts, etc. So there is a guarantee that I am able to maintain the ventilation rates that I require. And ventilation through dilution, that means I'll explain to you in very, very simple terms what dilution, if I want to explain to you. Take a bottle of water, a plastic bottle of water, which is filled up with water, make some holes at the bottom, tiny holes, and you'll have water leaking out from those holes. Then put this bottle under a tap of water and start filling that bottle. What is happening? You are leaking out the water, and at the same time, you are filling fresh water from the top. So effectively, over a period of time, the entire water in that bottle would have got replaced. Though the bottle is always full, but it's just getting replaced continuously. That is exactly what we talk about ventilation by dilution in a room, that I'm continuously replacing the air in this room at a particular rate, so that even if there are particles in the air, or for example, there were particles in that water, that particles are going out and being replaced by fresher water or outdoor air or fresher air, as we call it. That's why it is important to have a mechanical system to ensure I'm able to ventilate. Also, I can run it through filters to filter out the particulate matter or these large particles from reaching the breathable space. One very important thing is that unconditioned spaces, especially in our weather conditions, where we are going to be touching, say in parts of India, we're going to be crossing 42, 43, 45, or in parts of India, we're talking about the humidity levels going to 90%, 80%, which is very uncomfortable. Unconditioned spaces, specifically to workspaces where office spaces are, because most office spaces are sealed spaces, do not have the right amount of ventilation, natural ventilation at all built in over there, will cause people thermal stress. And if I am under thermal stress, I'm actually losing my resistance to fight anything else, because my body can do a few things at a time. So I am under some other stress and my body is in some other stress. So it's fighting. And when I'm fighting one thing, my body loses the power to fight something else. So I could actually be more susceptible to catch some other infections. Hence, we are saying that use air conditioning and ventilation with the right precautions in the right manner as the right system, operate and maintain it properly. Now let's look at the most important thing, which is humidity. What is the impact of humidity on this virus? You've all read about people saying, increase the humidity, at high humidity, this virus will not survive, etc. The true word should not have been high, it should have been higher. That is precisely because when this virus came into being in places like China and then went to Europe and US, those places were very cold in the winters. And when it's cold, when it is winter, the air is very dry. Those of you from Delhi would vouch for it. In December and January, the air is very dry. That's why your skin starts cracking up and drying, etc. So those humidity levels are very low. So those humidity levels need to be taken up to a higher level. So what is the higher level? There are three aspects that we look at it. Number one is, at what humidity is this virus effective or infective? Infective is the word which is more applicable over here. That means this virus is infectious or not. All virus is not infective. It's not that every virus that come out will infect somebody else. So after a lot of research over many, many years, again done on various other kind of viruses and bacteria, etc., with lipid and without lipid membrane viruses, it was discovered that this band of 40 to 70, 40 to 60% is the band when this virus is the least infective. So this is why one idea came out, that one of this theory is that 40 to 60, 40 to 70% is the right band for this virus to have the less chances of infecting somebody or even surviving. So this was issue one. Issue two is very simple. When the air is dry And when a droplet comes out and falls on a table or an object, the water will evaporate faster because the air around it has no moisture. So this droplet is able to evaporate faster. A droplet becoming larger is easier to control. A droplet becoming smaller is more difficult to control. So it will evaporate faster and the smaller particles will remain in the air for a longer time. The moment that more room is higher on humidity, has more moisture content in the room around, it will take much longer time for that water to evaporate. So the surfaces can be cleaned and we ensure the virus does not go up in the air. Also, again, my friends from Delhi would remember in those dusty, dry days when it's very dry in the summers in Delhi, it goes down to 30, 35, 40% humidity and very hot. And the weather is very dry, you will see a lot of dust in Delhi because whenever you clean the surface, the dust will get resuspended and then again gets resettled down because the air is very dry. There is no moisture to trap those particles. So this is the other impact of humidity on this virus, that the infectious droplets will shrink, can travel far, and also it is difficult to clean the surface when the air is dry. The last thing on humidity is to do with our body. Our body is a unique mechanism. It has all kinds of systems inbuilt to be able to fight all problems up to a large extent, including our respiratory system. We have immense filters, if I can use that word, at various points, starting from a nasal passage in the hairs, going down to a lower respiratory tract, where we have enough protection to be able to capture particles before they reach the lung. So one is the mucus layer, which is supposed to be very moist. When it is moist, it attracts particles. The moment this mucus layer becomes dry, larger particles will not be caught and they will go deeper into our lower respiratory tract. In the lower respiratory tract, also we have the bronchi and the alveoli, which trap the smaller particles. Hence, if the humidity is low, if I am taking in dry air, more and more of dry air, breathing in dry air, my system will go dry and particles will be able to reach my lungs better or faster. So again, it is advisable always to be breathing in moist air. We all face the same thing when we say ki mera gala sook gaya, my throat has gone parched, dry because of the weather conditions also. This is the same thing that's happening over there. So these are three issues and three impacts of humidity, of low humidity, and that is why we have recommended as ISHRAE that the best humidity band is 40 to 70%. Anything in this range is the right suitable environment for humans and to decrease the problems from these pathogens. Anything higher than 70-80%, there are a lot of other problems that come our way, and we'll have fungus, mold, and we'll have asthma patients suffering, and we'll have this problem different, and other problems will start. Hence, we do not recommend beyond 70. 40 to 70% is the band that we talk about. Then coming to temperature, there have been a lot of things about this temperature impacting the virus, and people saying that take the temperature high, and at higher temperatures it will die, and etc. etc. And a lot of research has been done on this in the past on, say, the influenza, flu, etc. And it said in air at 7 to 8 degrees was the best temperature for this flu to survive. 7 to 8 degrees. And with this temperature rising and then gap, that range of 20-24, the chances of survival decreased. And going at 30 or a little bit or more than 30, the chances further went down drastically. This is now in the air. The other study that was done was on surfaces, and it was said or discovered that if a surface is at 4 degrees Celsius, a virus can last of up to 2 weeks. If the surface is at 37 degrees Celsius, the virus can last up to 1 day. And if you make it at 56 degrees, you can last it to 30 minutes. Now, there is no way that we can ensure a surface to be at 37 or 56, even by switching off air conditioning, switching off fans, opening all the windows. There is no way you can achieve this. So going at all these paraphernalia and these readings, ISHRAE recommends that a temperature band of 24 to 30 is the best temperature band to ensure the infectivity level of this virus and our resistance to thermal resistance. In humid weathers, humid climates like coastal cities like Mumbai or Delhi or Chennai or the coastal part of India, where the humidity levels are higher, we recommend set the temperature at 24 degrees. And in drier places like Delhi, etc., set it at 30 degrees and then use a fan to increase the air movement. Because if you actually use an AC at 27, 28, 30 and run the fan at a lower speed, you will realize that it is actually very, very comfortable and you can easily manage your work or otherwise in that temperature. Now let's look at some applications. I'm going to skip the room air conditioners because since we are talking more about commercial buildings, I will not spend time on this. If there are any questions that come our way, we can also take them up in the end. Let's look at commercial facilities. The biggest challenge in a commercial facility, in an office space, is that we will always have multiple occupants. You will also have many visitors coming in. Occupants will come from all over places, from different cities, from different localities, etc. Same with the visitors who will come in for a short time of 10 minutes to 1 hour or 2 hours to meetings. And you cannot control that. That is the whole purpose of having an office, that you will have these people coming. Hence, the air conditioning system becomes the most important thing to control. And the only and the best way to limit the risk of COVID-19 infection by air is to ventilate the indoor environment by and using outdoor air best possible levels. Now, sir used this example of this restaurant in China, which had come in media and got a lot of coverage with a lot of nice looking drawings and readings attached to it. Unfortunately, that the report was a nice report, but it was not read or communicated very, very properly. Now, please understand that restaurant did not have a central AC system. Firstly, that restaurant had simple high wall AC, split ACs installed. The virus did not spread through the air conditioning system. The virus, firstly, I will totally believe the report. I understand the report is 100% right at this point, though I have my other reservations against it, but let's assume the report is 100% right. What happened? The table which was nearest to this split AC had somebody who's infected, and he or she coughed, sneezed, or whatever, and these droplets came out of the person's mouth or nose. Air was blowing, the AC air is blowing, and that air, when it's blowing, the particles are also blown away from this table one to the other table, and the other person got infected. That is broadly what happened in this scenario in this restaurant. Now, please imagine that person was told, restaurant was told, please don't run the AC. No problem, put the AC off. But you need to do something, so run the fan. Open the window. Are you telling me that a fan running does not have a blast of air, does not have a draft of air? Everything has a draft. So this virus was caught in a draft and it went from table 1 to table 2, which cannot be prevented because of not having air conditioning. In fact, if the person had installed the right air conditioning system in that restaurant, had provided enough fresh air coming in and the right exhaust out, the particles would have got taken away through that ventilation route and not possibly spread. So ventilation and air distribution in the right manner is the best way to control, rather than just opening up windows and running the fans in such commercial places. So what are the key operating guidelines that we talk about? Obviously, keep the filter clean, which is the most important thing at all times, COVID or no COVID. Please ensure that the adequate ventilation has been provided. We have given some norms and some numbers in our manual. Those are the bare minimum. We always recommend at this time to go as high up from there as possible. Obviously, every system will have its limits. You cannot go beyond a particular capacity, but say if my AHU is of 10,000 CFM, I at least give it 10% fresh air. I at least take it to 15% fresh air. I try and push it to 25% fresh air. Yes, you'll have to tell the occupants of that office, for these next few weeks, you might have to live with 27, 28 degrees inside instead of 23, 24, what you have been used to. They will have to accept a little bit of discomfort so that the air remains ventilated. Fresh air that comes in should preferably be provided through mechanical means, through a fan, and not just assume that I have given an opening in the wall and through the opening my fresh air will come in. No, we would prefer to provide fresh air through a fan supplying fresh outdoor air to the back of this air handling unit. If possible, if you're not able to take a load, look at adding a treated fresh air unit that will help reduce the load of this fresh air on your air conditioning system. In very small offices like 200, 500 square feet offices, or within a large office, you have smaller rooms. If you're not able to bring in ventilation happening, try and open the windows. I was telling somebody recently, if you're not able to bring in exhaust in those smaller offices, it is not difficult to put up the small exhaust fans, the small plastic propeller fans. Put up an exhaust fan in that room so that you're creating a path of air to be ventilated. So look at ways and means of ensuring that the air in a room is getting replaced as often as possible. That is the mool mantra. Replace that air in that room as much as possible. Keep the coils clean. Set the temperature and humidity as what I have told you earlier. Ensure that the toilet and the kitchen fans are kept in operating mode, so that creates again a path of air for the same to move. It is advisable to not run the wheel if you have a heat recovery wheel during this pandemic, during this COVID time, pandemic times. It is advisable that you do not run this heat recovery wheel. Today, bulk of our industry, the air handling units, have some kind of a filter installed always. What level, what rating, it's not fixed. It keeps on varying depending on client side to side. Our recommendation is to improve the filtration level from the current levels. Number one, ensure that it is certified filters. These are rated filters. These are not unrated filters. Ensure they are rated filter. Try and take them to a MERV 13. You can read about this and what the MERV 13 means, or I can share it afterward, those who are interested. Try and take it towards a MERV 13. That means a higher efficiency filter as much as possible. And if your air conditioning unit can take it. Try and install a UVGI light, a UVGI, to keep your coil clean and coil disinfected. Inside a larger air handling unit or the larger ducted units, you can install this UVGI light. Check that your HU is airtight. It does not have too many leakages, because otherwise air might travel without passing through the filter. It might bypass the filter, which is not advisable. Now, how do I start up when after lockdown, I'm going to reopen my facility after a gap of 5 weeks, 6 weeks, some places could even go to 8, 10 weeks that the offices were shut and now you're opening it. It's not that you can just open the door and start work. Imagine your own home, you've gone on a long vacation of 2 or 3 weeks and the house was totally locked up. Obviously, you would have shut all the windows, everything very tight from a security point of view. Now you come back after those 2 or 3 weeks. What do we do as normal residents? We first come in and we open all the doors, we open all the windows. And we try and put all the fans on. That's the first thing we will all do at any level, small house, large house. It's exactly what we're telling our offices people to do. Only one thing added is that you should try and get the place sanitized. Apart from that, study the fresh air and exhaust air. That means doors and windows. In offices, you will not have too many windows. So you have to have a mechanical fresh air and a mechanical exhaust air system. Study it and see if you can modify it to increase the fresh air as much as possible. Follow the protocol of maintenance. Clean the filter, disinfect the filter, clean the drain pan, disinfect the drain pan, clean the coil. If you have ducts running in your system, try and get the ducts cleaned, try and get the ducts sanitized. Open all the doors and windows of the space, as I said. Ensure everything is sparkling clean and disinfected. Run the fresh air system at the maximum possible levels. Then run the exhaust systems at the maximum possible levels. For 2 hours to 4 hours, run the air conditioning without AC, just the fan mode. Do not switch on the cooling, just the fan mode for 2 to 4 hours. And with the fresh air exhaust air operating, then after installing the filters, again run the AC with cooling mode, but keeping the doors and windows open. We call this process as flushing a building in and out. That means I have replaced the building air multiple times, so that anything in that room, in that air which could have got built up, is all thrown out of the whole place. It is advisable that even during weekends or offs, run your fresh air system, run your ventilation system, at least for some more days or some more weeks till this COVID menace is all over. Same thing, we have given guidelines for various kinds of equipment, that is smaller units, cassettes and high walls, which you can read the manual and understand from there how to handle various kinds of other equipments also. We've also given recommendations for kitchens over there. I'm not going to read it out right now. It's there in the manual. It's there in front of you. It's a similar protocol that I have to flush out my kitchen. I have to flush out my ducts and replace as much of the air as possible in that premises. We have also done a recommendation for some industrial facilities, which is large factories which have either normal ventilation, or they have air washers, or they have evaporative cooling, depending on the kind of the factory and the kind of process that is done over there. And we have given very clear recommendations for those factories also. When they start up, what should be the procedure they should be following. We've also put in some safety guidelines for technicians. I'm not going to go in those over here, but in the manual, they're mentioned in great detail, so that when you are working with air conditioning team or conditioning companies, it is important that they are following these safety protocols for themselves, for their company, and for you as the clients. Everyone should be concerned about safety of manpower, because finally everything is about human lives. So these are safety guidelines also put over there. I would now like to hand over to Mr. Gautam Baliga, who's going to take us through the healthcare part of this guidance document and brief you on that. Gautam, over to you.
Thank you, Vishal.
We'll have to keep the timings also. We have to take care of the timings also. We are already at 2:46. Thank you.
Yes, I was told 40 minutes for the presentation, so I have taken 30. Gautam will take 10.
Okay. Thank you.
Let's start. Okay, the healthcare sector has been challenged by the COVID-19 pandemic like never before. Hospitals are our first line of defense. Most hospitals, even the 300 to 400 bed hospitals, have only 2 to 3 isolation rooms. Now they are overwhelmed with requirement of huge number of negative isolation rooms and quarantine facilities. The ISHRAE COVID document gives guidelines to tackle this acute pain point, to convert existing rooms into the new requirement. So what we have is COVID-19 positive patients and patients with COVID-19 related symptoms. They have to be accommodated in designated airborne infection isolation rooms, as they are called, AII rooms, in hospitals to control the spread of the disease. The most important factor is that we have to ensure that the virus-laden airborne particles from the patient do not leak out of these rooms occupied by the COVID-19 patient, and also to maintain the concentration of virus-laden particles inside the room at a minimum. This is required to control the spread of the infection and also to protect the healthcare workers who have to attend to him. Next slide. Vishal. So the basic things that we need to take care of, that we have to do no harm to the patient. The system arrangement should protect the workers. The system arrangement should protect the other patients who are there in the facility. And airflow has to be from clean to less clean. That is, the clean is to the patient and less clean goes out of the room. Next. The specific guidelines are convert, when you are trying to convert the room into a COVID-19 room, convert into a non-recirculatory system, 100% fresh air. The normal rooms, we recirculate the same air, but now we are going to talk of systems where the air is not going to be reused at all. So make sure that the AHU will have provision to receive adequate outdoor air. It is because, as Vishal has already emphasized, that is the dilution process, the outdoor air. The outdoor air source for the AHU shall not be from within the building, and all care should be taken to avoid intake of outdoor contaminants to the best possible extent. What it means is, before you take the air in, determine where it's coming from. Next is independent exhaust blower shall be provided to extract the room air and exhaust it out into the atmosphere, preferably after suitable exhaust air treatment, because it's dangerous air. Next. The specific guidelines are the exhaust air quantity shall be greater than the supply air quantity. So you maintain a negative pressure of a minimum of 2.5 pascals, preferably greater than 5 pascals, so that the air from inside the room does not leak out of the room. It is advisable to install differential pressure meters to measure this metric, because unless you see that it's negative, you're not very sure whether it's negative. And lastly, the supply air quantity shall be such that it will provide a minimum of 12 air changes per hour. That means the air inside the room is changed 12 times in 1 hour. And the position of the extract air has to be such that the whole exhaust directly goes out of the room. The exhaust air is mostly likely to contain particles carrying viral load, and so suitable technique has to be employed to see that it is eliminated from the system. So treatment by HEPA filtration of minimum H13 grade filters have to be there, and these have to be verified that they are of this particular grade. And if you cannot put HEPA filters for whatever reason, you can go for treatment of exhaust air by chemical disinfection. And when even both these methods are not really possible for whatever reason, then it is better to take that exhaust air far up into the atmosphere, at least 3 meters above the tallest point in the building, and then release it so that it gets dispersed into the air. And if both these options are not possible, then you can go for exhaust air treatment with UV irradiation or heating, but both these require some special attention. UV of particular residence time, heating of particular temperature and residence time. So you have to know that, and that is all spelled out in the document. Next. So we have talked in the ISHRAE COVID document of two types of things that can be done. One is create an isolation enclosure. The previous slide, please. Create a temporary isolation enclosure, and from that enclosure, in the front you have those PVC curtains and you have an exhaust air. So you suck the air conditioning from the ward, and the patient who is in the bed, he's kept clean, he's kept cool, and that exhaust air goes into a some sort of a chemical cistern, and then it gets exhausted after treatment. By this, what we are trying to ensure is that the area is mentioned at it is maintained at 2.5 negative pascals. So next. The other is you can have a isolation cabinet like earlier, and then you can the previous, yeah, and then you can have a fan and a HEPA filter unit which sucks the air through the PVC curtains which are in the front, and that air, because it has been treated through the HEPA, it can be put back into the room. So the purpose of this is to have the room at a negative pressure, and the treated air is then safe. Next. Next is we are talking of COVID-19 quarantine facilities. The NCCD guidelines for quarantine require social distancing, minimum of 1 meter between the beds, and the area can be having natural ventilation, which is again, as Vishal pointed out, going to be very difficult to ensure. And if provided with mechanical ventilation, there shall be supply and exhaust fans. Next.
Oops, sorry.
Previous. Yeah, if air conditioned, these quarantine, what are quarantines for? Basically, the quarantine is for patients who are, not yet confirmed COVID patient. They are under investigation. So they have still not been confirmed to have the COVID, and for something like 14 days or so, they will be kept in the room till they are confirmed to be COVID positive, in which case they go into the isolation room. This is the temporary residence. So if these places are air conditioned and using AHU, then you ensure that the AHU is not shared with other areas, otherwise you'll cause problem for them. Close the return air outlets and run on 100% fresh air. Have exhaust fans to maintain the area in negative pressure. The idea is the supplier has to bathe the patient, means he gets the clean air, and the exhaust air then is led away from the patient. And if it is air conditioned with unitary equipment like high walls and split ACs, even this can be accepted, but you definitely have to have these exhaust fans to keep the area under negative pressure. This exhaust fan also will ensure that it will induct fresh air into the area. So this is what is specific for the healthcare systems. Thank you.
Thank you. Thank you. Thank you, Gautam. I'm sorry for everyone. We had to go a little fast because this presentation otherwise itself is around 75 minutes and we had to condense it down. So we had to go a little fast. We've had a lot of questions come in, and obviously it will be difficult to handle all the questions. We'll try and revert back separately, or you can even note there's an email ID called COVID, COVID, at ISHRAEHQ.in, ISHRAEHQ.in. Jitendra or Anuj, if you can take over the screen and show that email ID again, and I will ask the questions after that. Okay. So the questions that have come to me, I'll take one. A very common question that has come to us is on filters. There are multiple questions. I'll try and put them all together. The questions are as follows. Number one is, can we install HEPA filter in an air conditioning system in a commercial space? You can install any filter anywhere in any system. But for a commercial space, installing a HEPA filter, the challenges will be too many. The pressure drop across the filter will be very high, and it will not be possible for your existing system to handle that at any cost. So you will have to reconfigure, reinstall, modify your entire equipment. Also, the energy cost of a HEPA filter in a main air handling unit is substantially high, and the replacement cost. So for a commercial space, a HEPA filter is not that real requirement. But if you want to, you can, if your system is about to, can take that HEPA filter. So that is to do from a HEPA filter point of view. UV light in the ducts will have very little impact because we need a minimum amount of time the air comes in contact with the UV light for it to be disinfected. It's approximately to the tune of around 15 minutes, though in an AHU system, it's a few seconds in actuality. So a UVGI light, UVGI system is very good to be used to clean a surface like a coil or maybe even the drain pan, but not so much so to cool the coil. MERV 13 filter is what has been recommended in our guidance document to be installed as the best line of protection, because most systems normally do have a MERV 13 filter installed, or if you do not have a MERV 13 filter installed, you can look at getting your system in most probability fitted with a MERV 13 filter. Other question is, one second, how good or bad are air coolers which are used in public offices? Richie, do you want to address that?
Yeah, thanks, Vishal. So just a quick one on desert cooler. Desert coolers are one thing which we need to be cautious about, that there are a lot of desert coolers which are available, which you normally keep it in-house. So we have to make sure that it is drawing the outdoor air. That is number one. So they are safe. Only thing is that we need to change the water more frequently than we would have been doing. So I mean, water is in scarcity, I know that, but yes, we have to clean the water of the tank, of the cooler tank. And number three is we have to be careful on the exhaust. We need to make sure that we have a proper exhaust while installing the cooler at home, because I'm sure all of us know that we open the windows, and if you have exhaust fan in the toilet or kitchen, and while you are using a desert cooler, please do that. Thank you, Vishal.
Okay. Question has come in. How do you have dilution in offices which are air conditioned with VRF and have no treated fresh air unit? If with the system is like highballs and cassettes or smaller systems where you have not laid fresh air, obviously in such a short time, it will not be possible for you to lay a whole fresh air system. Though please note, providing outdoor air is not a need only of today. Providing outdoor air has to be there at all times. Every guidance document of the world on air conditioning ventilation says always provide outdoor air, because otherwise it is very difficult for anyone to stay inside that place for too long. The air quality, the CO2 levels will really go up. So if you have a space like that, first option is try and open the windows. Another option is to try and add in some exhaust to those places. Another option is try and run a normal fresh air system through some small ducts and supplying some amount of fresh air, even if it is raw fresh air, into those smaller rooms. But eventually you will have to plan to install a fresh air system. In the meanwhile, you can do any of these things that I have been recommending to you. Another question is, kindly confirm in district cooling in industrial offices, return through fall ceiling without return duct shall be closed in COVID-19 times. Return through fall ceiling happens in nearly all applications in the world, more so in our country. Offices or industries or everywhere, 95% of the HVAC applications, the return air is through above the fall ceiling, and we do not have return ducts. So we are not saying to stop the return air in totality, but the moment you will increase your outdoor air. So a simple calculation, if my AHU is of 10,000 CFM, so my return also is 10,000 CFM. If I bring in outdoor air of say 2,500 CFM, that means my return air now will become 7,500 CFM. So this extra 2,500 cfm of return air, instead of reaching the AHU, will now be exhausted out either through the toilet exhaust fan or through door openings or through other openings into staircases and open area. It will go out, and that is how I am replacing the air inside. So no, you do not need to shut your entire return air, whether you above false ceiling or through duct, but reduce return air and increase outdoor air to the best possible level in your system. Is speed of airflow also play an important role? From this virus point of view, as I gave you the example of that restaurant, air draft positioning, yes, can have a role of spreading this virus. Speed, possibly yes, but anyway, normally in air conditioning, while designing, whoever has designed your ducted system would have taken care of the right velocities to be maintained across the duct, across the grill, across the outlet. But yes, drafts should be kept in mind. As of now, there's no proper research done on that from this COVID perspective. But in general, a draft of air is advisable to be avoided in offices. We have talked about that the humidity levels need to be monitored or controlled within a band. So the question asked is that most buildings do not have RH measurement or control. Please suggest how to maintain required RH. A very right question. Most buildings do not have humidity controls or measurement, so it is advisable that try and put in these meters which read temperature and humidity. They are very easily available. Put them inside a premises or tell your air conditioning operator to start taking readings of humidity also. As long as the humidity is in that band of 40-70%, you are safe. If you are falling below 40% or going beyond 70-80%, is when the time you'll have to start looking at making some changes to your system. That means either you have to start humidifying your system if your humidity level starts falling down to 25-30 in your office, or if it starts going to 80-90%, there is something wrong in your air conditioning design and it is not dehumidifying enough. So either you have to look at the coil of your air handling unit, or you will have to look at possibly even air handling unit over there. I think there are many other questions I've tried to address as much as possible.
Vishalji, we shall be overshooting the time.
Yeah, so
I would request you please take the questions.
Yeah, so I'm just taking last one or two questions if anything is left out, because mostly either we've addressed in the presentation. I'll take the last one, which is to do with residential application. Okay. Is using AC at home harmful in current situation? No, it is not harmful. Our document says you can use the room AC at your home. Keep the window open by 2-3-4 inches. You will obviously have an adjoining toilet. Run the toilet exhaust fan, again ensuring that there is a gap between the door and the wall in whichever manner, so that there is ventilation always happening. So you can run your air conditioner, try and keep the temperature 27, 28, 30 with your fan running to be very comfortable.
Thank you.
So
thank you,
all.
Vishal.
I have many other questions, but obviously, shortage of time, we can't handle all the other questions. Thank you, MP. Over to you, please.
Thank you, Vishal. Before I invite Mr. C.K. Verma Sahab, Chief Engineer, Mr. Pradeep Mittal would like to talk for a minute. So Jitendra, can you please put Mr. Mittal for a minute? Jitendra?
He's there now, MP.
Mittal साहब अपना कैमरा ऑन कर लीजिए.
मेरा कैमरा ऑन वहीं से ऑफ किया उन्होंने, जितेंद्र जी ने.
Sir, you are on. Please go ahead. Sir, you are on. Please go ahead. We can hear you.
Okay. मैं आज का वेबिनार बहुत ही सक्सेस रहा है. मैं रिची मित्तल जी, विशाल कपूर जी, गौतम जी को बहुत बहुत धन्यवाद देता हूं. और ओवर रिस्पॉन्स जो मिला, शुरू में अनंत कुमार जी ने बताया कि इट वाज 501 मोर देन द कैपेसिटी एट द इनिशियल स्टेज. तो हम सबकी टीम, ये ISHRAE की टीम और इंडियन बिल्डिंग कांग्रेस के मेरे स्टाफ को भी मैं धन्यवाद देता हूं कि उनके सबके प्रयास से इतना सफल रहा. अगेन आई आल्सो रिक्वेस्ट ऑल द पार्टिसिपेंट्स टू बिकम द मेंबर ऑफ इंडियन बिल्डिंग कांग्रेस. जो अब तक नहीं बने हैं वो उसके मेंबर बने, जिससे इस फील्ड में हम अब अगले हफ्ते फिर आपको जिससे सबकी सूचना हम दे पाएंगे. और नए नए टॉपिक्स पे लगातार इंडियन बिल्डिंग कांग्रेस इस प्रकार के वेबिनार आयोजित करती रहेगी, क्योंकि कोरोना का माहौल तो पता नहीं कब ठीक होगा. कि ऑन द सीट आकर कॉन्फ्रेंसेस करना बड़ा मुश्किल होगा, लेकिन वेबिनार के जरिए आज की सफलता को देखते हुए हम इस काम को लगातार करते रहेंगे। नेक्स्ट वीक फिर पुणे हमारा सेमिनार होगा और पुणे आप सबका धन्यवाद।
धन्यवाद मित्तल साहब। अब मैं सी के वर्मा साहब से रिक्वेस्ट करूंगा वो अपने कंक्लूडिंग रिमार्क्स दें। वर्मा साहब, वर्मा साहब अपना वेबकॉम ऑन कर लीजिए। नमस्कार वर्मा साहब, प्लीज। मैंने
वेबकॉम ऑन किया हुआ है, लेकिन पता नहीं आई एम विजिबल और नॉट। मे बी
ऑडिबल तो है, आप ऑडिबल हैं, बिल्कुल ऑडिबल है।
It looks like the novel corona effect has come now on my image. Anyway, I will conclude with the remarks that it was a very exhaustive but short session which has been attended by a maximum professionals across the country. So the viewership was maximum. That indicates the people are very much conscious of the air contamination, which may be the likely cause, and we are seeing in the TV, in the YouTube, and in other social websites like Facebook, etc. There is a lot of talks going on about this COVID-19 and air conditioners, coolers, and fans. And I hope this session was able to address most of the concerns of the common man, and on professional front, HVAC engineers are also benefited, but I am getting more and more questions from different professions, like from the dental, from the other organizations, which I am forwarding to ISHRAE, so that ISHRAE can examine them and can come out with the solution which definitely satisfies the maximum audience. And with that I conclude, but I will be failing in my duty if I do not talk about Mr. Pradeep Mittal, who is the president of the IBC and has taken the lead, and our ADG, Mr. Anant Kumar, who has been instrumental in spreading this awareness through ISHRAE, and of course Mr. Richi Mittal, Mr. Vishal Kapoor, Mr. Gautam Baliga, and above all Mr. MP Agrawal, who has been in contact with me. I express my gratitude to all of them for this very nice session, and all the presentations were very beneficial. Thank you very much.
Thank you, sir. A big thanks from ISHRAE, all the participants. Namaskar. Stay safe, stay indoors, stay active and agile. Thank you very much.
Hello.
Jitendra,
Hello. Next time we will hold any seminar, we will keep the capacity to 1,000.
Right, sir. We will do that. Thank you, sir. Thank you.
Thank you, sir. Thank you, sir. Thank you.
Any topic, we will have the capacity for 1,000. You see that.
Thank you, sir.
Okay,
any challenge throws the opportunity. Also, probably we could not gather 500 persons for a seminar even in the auditorium. So if we can go up to 1,000 for the next seminar, it will be really wonderful. Thank you. Thanks all.
Thank you.
Yeah.
Thank you. Jitendra, you can switch off. Thank you, sir. Thank you.
Thank you.